This conference will now be recorded.
Yeah. What I'll also do is all the files I'll save into Google Drive and we'll share with you. So you both will have access to them. I'm also looking into can we move to something like Google Classroom where things will be more systematic. So in a few days time I'll settle that, and then if that is better we'll move to that spot.
Sure. Yeah.
And in the meantime, actually, even before we start, can you're connecting from your laptop, right?
Yeah, I'm connecting from laptop. Yeah.
So can you go and download this software, which will be used for like our practice and so on. So on Google, you can search for Anaconda
Okay.
and just open the first link and go to products, individual edition, and you can download. And then you're on a Windows system or Mac system?
Windows.
Yeah. So you can download maybe 64-bit Python 3.7 graphical install. So in the meantime, we'll start, and in the background you can start downloading this software.
I think I already have Anaconda. Yeah.
Okay. Have you worked with Python before?
No, but I was just looking through the online courses and I was just able to download and I installed the Python, this Anaconda Navigator.
Oh, great. So do you also know how to start Jupyter notebooks?
No, I don't have idea.
But you have installed the software on your system.
Yeah.
Yeah. So by the end of this course, we will then I'll allow you to you share your screen, and then we'll guide you through the process of starting the notebook and doing coding there.
Okay. Yeah.
So here we'll start with data analytics with Python. So just to get the basics on the floor, why should one choose a career in as a data analyst? So few reasons are Harvard Business Review says that it's one of the best jobs for the 21st century. Frost and Sullivan gives a survey that the global data science market will reach $122 billion in revenue by 2025. And in 2019, within US alone, a shortage of 1.4 to 1.9 million data analysts will be realized. So these are like top names that give these figures, and we don't need these names because if you observe how major companies and MNCs are moving, you can see the clear trend that data scientists and data analysts is a huge demand. And probably one of the reasons why many people are taking up online courses and they're upskilling within this area, just analyzing how we can leverage the huge amounts of data that is being collected by so many different corporations, and how we can leverage that to either give business insights to the company that they can make better decisions and enter into areas or leverage that data for better solutions. And uh, a huge amount of that happening raises this awareness and scope for people to enter into the field and do things. Some more stats that we have is the data professionals were asked what is the best source of new talent for data science, and we see that people who enter into the field of data science come from a variety of different places. So we've got 34% as computer science students, 27% as professionals in fields other than IT or computer science. So people even from other engineering backgrounds are entering into data science. We've got students in other disciplines entering into data science, 24%, and around 12% business intelligence professionals and 3% other. So if you look at the spread of where the data science talent comes from, it's not just computer science. It is spread throughout the field. And once this happens, it opens up like the playing field becomes flattened for other people who are interested in data science. And we soon find out that data science does not prerequisite programmers or does not prerequisite computer science. It's a very generic topic, and depending on how we apply it, how we take principles from different domains and align them with data science principles, there's a wide scope of people who can enter into data science. And we discussed this already within our overview, but let's go through this again. What is data analytics? So data analytics is the process of finding information from data to make a decision and subsequently act upon it. There's a very broad definition of data analytics. And as we go deeper, we'll see the nitty-gritties of how it is spread around and how different parts of data analytics, different tools and algorithms, they come together so that we can actually uh, use them in collaboration to make these decisions and how to act upon it. Also, Srinivas, if you need to stop me and ask me a question, or you think it's slow, or if you think it's fast, you can accordingly tell me, and then we can either speed it up or slow it down, or answer any questions in between as well.
Okay, sure. Yeah.
So what's the need for analytics? So three main areas. We are now having large amounts of data which is being collected. So from all over the space, from business transactions, from online interactions, advertisements, just sensor data from a lot of IoT devices, and that's one reason where we have huge amounts of data being collected. Second is huge amount of data can be saved now at large data storages. So we've got we've got cloud platforms where we can store a lot of data, and this data can be accessed in different places. This data can be transformed, modified, cleaned, and accessed throughout different places. And now we've got the technology for doing that. And finally, the third, with huge amounts of data, we've got better tools and technology that can analyze or we can work upon that data. So all these three things, when they come together, that gives us the need that okay, now we need to do analysis over it, because raw data as such is not useful at all unless and until you can draw insights from that raw data. The data just remains useless. And just to give us an example, we've got data harnessing companies that are storing each and every piece of information generated during business operations and customer interactions. So a huge amount of data is being generated, data is being analyzed, and learning from that data can be used in decision-making process and optimization. So just to give an example, for 2000, so this is the number of transactions for Walmart. So there are approximately 4 billion number of transactions every year, and among the 900 stores and about 1 lakh units of different customer interactions. We've got within this, we've got huge amounts of data that is being collected for Walmart. So as they report in 2012, they were collecting around 1.2 trillion GBs. In 2015, 2.4 trillion GBs, and 2019, 5 trillion GBs. So as the years go by, the data that is being collected is growing exponentially, and we can then utilize this data and make decisions. So we've got some examples regarding supermarkets on how if you collect the items and sales of different objects, how we can predict what will be the sales for a particular item in a particular outlet for the next month, the coming months. And if we have access to that information, you can save a lot in logistics. You can plan ahead on how the sales will be. You can find out seasonal trends from what has happened in the past. That will give you some idea on how we can leverage this information so that you can better manage things and thereby increase the profitability of the company. When you look at analytics as a whole, we can say that analytics can be further classified into three main areas. We've got the computer science and IT area, the math and statistics, and then the domain or the business knowledge area. So yes, to implement many of the algorithms and to work with the tools, we need access to computer science, and we need access to programming and tools that are available. But that is just one part of the game. A huge part of data analytics comes from the algorithms that we use, the mathematics and the statistics. So we use a lot of maths and stats throughout data science, ranging from linear algebra to calculus to probability and statistics. And that is another main area where people are required who are experts within this. And ultimately, the business knowledge or domain where we are actually implementing it. So if you're applying it on an advertisement problem, then a knowledge of how advertisement works, what are different touch points, how we can generate leads and convert those leads uh, to actual conversions, that is sales, and all of that information is also useful. So analytics is basically where all these three come together, and we can draw out solutions. So in a basic data analytics team working on a problem, you would have some programmers who would be doing the actual coding. You will have some mathematicians and statisticians who would uh, who would what do you say who would show on what is next to be done, or how we can take a huge population of data, sample it, and give your basic analysis on what's the next part. And people who come from the domain, so this generally happens. You're working on a client, and a few of those experts of clients will be part of your team to guide the basic principles on how what data is important, what data is not important, how we can do feature engineering, and so on. So a general data analytics team would comprise of these three areas. And what we aim to do is getting a base idea of all three components, so that we stand somewhere in the center point where we can quickly maneuver and move to any of the areas and contribute within that space. Key types of analytics, as we saw earlier also, is we can take and we can talk about descriptive analytics, predictive analytics, and prescriptive analytics. Descriptive analytics is what has happened in the past. So taking previous data, plotting it using different visualization schemes, and verifying how things have worked in the past, collecting large amounts of data and putting it into a data warehouse, and analyzing that. And that is one part of analytics, that is descriptive analytics. The second interesting part is what is going to happen in the future, what will happen in the future. And this is where we incorporate machine learning algorithms with our data, which is able to predict or classify information on what's next. And once we have that information, we can use that information for profiting, increasing business, and doing so many more things. But even with that, the next step of analytics would be, if you know what is going to happen next, analytics can further help us into what is the best possible outcome. So based on what is going to happen next, you can take multiple steps, and which step will produce what kind of outcome. Uh, that is where your prescriptive analytics comes into picture. So examples of prescriptive analytics would be something like this. Why do airline prices change every year? So based on our past data, we can based on our past data, we can see what are the trends and how things work out. We can predict what will be the next price, and then if I know how airline prices change every year, we can probably generate advice on possible outcomes. How do we regulate this, or how do we make advantage of this as a consumer, as a person who's supplying this data service, and so on. Predictive analytics would be understanding the future. So how do grocery cashiers know to hand coupons which you might actually use? So instead of just getting random coupons, whether you use or not, we can have targeted coupons based on your usage, your profile with the supermarket or things like that. You can They can come up with custom offers which are suited exactly for you. And that is where we say, okay, based on what has happened in the past, they can predict what is the next step that you would take, and based on that, cater things according to your needs. Descriptive analytics is based on insight into the past. So how does Netflix frequently recommend just the right movies? So based on your user profile, what you have been doing in the past, how users like you have been seeing movies, and what movies you've been liking. It gives us a general idea of how these kinds of users, or you can club users into groups, and how these kinds of users react to different movies. And based on that, it is able to suggest the right movies for you to watch next. So within the space of analytics, we now move towards uh, different programming languages. So Python is primarily the most used programming language for data science and for beginners who enter into the field of data science. Not just beginners, beginners and intermediate and even experts. Even your final deployment is done in Python in many cases. So Python is an experiment in how much freedom programmers need. Too much freedom and nobody can read another's code. Too little and expressiveness is endangered. So Python, as we'll soon find out, that Python is very easy to read. It is very easy to learn, and that comes with its advantages and disadvantages both. Advantages is it is very it keeps a pretty low bar on entering the field. So many people can pick up Python and enter into it. And Python can also be modified, and many libraries and modules can be created, and it's very easy to do that. Which basically says that if it is if we allow too much freedom in how code can be written and code can be used by or shared, that basically says that uh, too much of it, and it will become difficult if people start developing their own standards. It will be difficult to read each other's code, and too much variety, and that is another problem that Python suffers with. But at the same time, it's advantages and disadvantages. So uh, it remains to be seen what will happen in the future, how Python will move and modify it further. Srinivas, do you have any experience with programming languages?
I just know like C, C++, Java, were like basic. I don't have real hands-on experience, but I just know the basics of it.
Some basics like operators and control structures and
Yeah,
functions and things like that.
yeah, like yeah.
So, great. So that's good, because then if you have some idea of how programming works, C++, Java are very good places to start. Learning Python will be much easier then, because then many of the ideas we can just transfer learning from those concepts to how things will be done in Python, and just knowing the syntax will allow us to do much. So we'll go into that and we'll see how it works. Okay. So just an overview of Python. What is Python? So Python is an all-purpose general language that works on multiple platforms. So whether you're working on Windows or Mac or Linux, people use Python. It is all-purpose, so it is not just for data science. Of course, data science is our key area of why we are doing Python, but it can be used for all sorts of things. You can write mobile applications, you can run server applications or stuff that will work online with Python. You can make standalone softwares. You can work on image processing to data handling and so on. So it's a very general language for automation and whatnot, and it works on multiple platforms. Python is high level and it is easy to learn. So high level is that we generally high level basically means that we are not dealing with the components. So we are not dealing with what is the controller, what is the RAM your system has, what OS you are having, and those things are very abstract concepts when you're writing code in Python. So we generally don't go to that deep level of how things work on the platform. Rather, we are focused more on the application, and that is what we mean by it's a high level. And making it high level basically makes it easy to learn also, because then you don't have to depending upon what your core is, how your system is working. You don't need to modify code accordingly. It is more commonly used for machine learning and predictive modeling, particularly good for academics and data scientists. So we will soon see that there are a lot of, and the reason for this is there are a lot of packages, very, very good packages that are developed for Python that allows it to be used for machine learning algorithms and for data handling and managing all of in the entire scheme of events, like starting from collecting raw data to deploying products on web services and on cloud and things like that. But in all of the space, Python can be used. So, which makes it very desirable for beginners to intermediate to experts to using Python. It is open source, so no one company owns it, and it is constantly being developed by uh, programmers all over the world in how it is progressing. It is free to learn. So you'll soon see that there's a lot of material available on learning Python, from YouTube to dedicated websites and blogs that help us doing that. And because of which it becomes so commonly used by developers. If we just look at some stats, in 2019, 30% or more people, they preferred Python over other languages like C, C++, Java, Perl, JavaScript, and so on. So there's a huge demand of people entering into or learning Python, and wanting to use Python in their future projects. And the reason it is so popular is maybe something like this. So if you see in Java, if I want to write a basic code for just printing something, I have to write public class main, and within that you have to provide it's a public static void main. You have to provide how the input looks like, use special functions that will output things on the console, and the same code or the same task to be done within Python would be just print hello world. So it takes a lot of the syntax away, and many things are done in the background so that we don't have to focus on precisely, we don't have to focus so much on the code. Rather, we can focus on what we are looking for, the answer that we're looking for from the language. Further, it is highly ranked on various lists of world's most popular languages, and that creates basically a feedback loop where uh, once you say that it is highly ranked, more and more people want to learn it, and more people start using it, and once that happens, it continues to stay higher on the rank. So many programmers, they view Python as a language with a clean syntax and an expansive library. So we'll see syntax is very simple. Many of the syntax is very intuitive on what we want to do and how we want to state it within Python. And it's got a huge set of library, which allows us to do lots of things with very little information on how they are actually happening. So, I talked about the feedback loop. Let's go ahead. So in further, even big companies like Google, Microsoft, and Amazon, and other major players, they even for their products they have used Python, which creates another industry backing that this knowing Python opens up space for working in all of those companies. So the advantage, it's easy to code, easy to read, it's free and open source, it is expressive. Expressive is it allows us to focus on the solution rather than on the syntax. High level, it is portable. So once you code, you can run the code in multiple platforms and multiple versions and so on. It's an interpreted language. So what I mean by interpreted language is, let's say you write a 10-line code and you have an error on line 8. With Python, each line is run independently. So you'll run line 1, line 2, line 3, line 4, and till line 7, the code will run fine. Line 8 has an error, and you'll get an error on line 8. Whereas had this been a C program, if you have for a 10-line program, if you have a error on line 8, then the program will never compile. You will never unless you solve that problem even before seeing the results. You cannot run the program. So this difference comes with its advantage and disadvantage. The advantage is, if I know how things are moving in my program, then I can debug it easier. I know that where the problem exactly is, and before the problem arises, what were the different outputs, and based on that, I can change the error, or I can remove the error on line 8. That's the advantage. So it makes it debugging really simple, and we'll see how that works out. The disadvantage to that is, since it is an interpreted language, that is, each line is run independently, it will make execution slower compared to compiled languages. So when you compare two languages like C, where C is a compiled language, and Python, so Python C programs would be slightly more faster compared to Python programs. So that's like the disadvantage of using Python compared to compiled languages. But when you look at the application in data science, we will constantly be doing or testing in a standard data science program. We don't exactly know what we want, and as we start exploring with the data, you will be trying different ideas and different things, and especially when you are experimenting with how things will work out, we want to change code multiple times. And thus, for us, for the data science application, Python becomes very useful because since I'll be changing code multiple times and trying out different ideas, debugging will be easier. And I want to run code in an interpreted fashion. So once everything is ready and I have the solution and things are sorted out, then we can port that code to C, or we can port that code to another language where it can run faster. But in the phase of exploring, speed does not matter so much at this point. So we can focus on more on the concept on how we can focus more on the solution rather than on syntax. That is where it is useful. Further, Python is an object-oriented language, so we can deal with objects and we can model real world. So in the real world, the entire paradigm is moved towards object-oriented programming, and we can do all of that within Python. We can have classes and inheritance and all those concepts that comes with OOPS language. It is extensible. That is, we can write some of our Python code in other languages. So let's say if you're more comfortable with C or C++, you for implementing a function or so, we can write C or C++ code within Python, and we can interpret that accordingly. It is also embeddable, that it works the other way around also. That once you have written a Python code and you want to take it to a different language like C or C++, you can transfer that code to that. You can port your Python code within that language as well. It comes with large standard libraries. So starting from unit testing to image manipulation to running websites or mobile applications, for all of these areas, we've got huge amounts of standard libraries available, and we can use them for different purposes. It is a dynamically typed language. What you mean by that is, once you create a variable, before putting the value, you don't need to define what that variable will store, how it will work out, and so on. Python is dynamically typed. So when a variable called as a, when you put a number, it becomes an integer variable. If you put an integer, it becomes an integer variable. If you put a float value, it becomes a float variable. If you put a character, it becomes a string, and so on. So as you go along, you can create variables, and depending on the context and how it is used, it will change its data type. We can do GUI programming, that means you can create standalone applications within Python using different libraries. So there's a library called as Skinter, which the short for that is TK, and we can use that for creating GUI programs. And it's a very good, because of all of these ideas, it's a very good fit for data science, machine learning, and artificial intelligence, because very, very powerful packages and libraries are available that help us to do all of these things. So a few of the libraries that we'll focus on, or a few of the libraries that are focused for data science, is this. On the left-hand side, we have these basic libraries. Matplotlib is a visualization tool that we use within data science. Pandas is a library that helps us to manipulate data, merge data, view data into data frames. Data frames are nothing but rows and columns of features, and we can manipulate all of this data within Pandas. Then we've got NumPy, which is numerical Python, and it helps us to do mathematical operations like linear algebra, probability, statistics, and all with our data within the Python framework. We've got scientific Python. Scientific Python is further like NumPy, but we can go more advanced. We can implement different scientific functions within SciPy. Then we've got advanced packages like Scrapy. So Scrapy is very specific to extracting data from the web. That is, if you know a website like Twitter or other places from which we want to extract huge amounts of data, we can write automated code for doing that. We've got Pillow, which is a graphics package, and we can manipulate images and morph them, do different things with images using the Pillow package. We've got Flask. Flask is a web service that we can create with Python. So different web services that can be used for mobile applications or websites and things like that. And PyGTK is again a package where helps us to create GUI programs using Python. So you can set up softwares and how softwares will work, your widgets and things like that within PyGTK. The applications that we can create with Python, they again, that's like a huge area. We can work on web and internet development, data science, science and numeric applications, artificial intelligence, GUIs, machine learning, software development applications, database accessing, network programming, games and 3D graphics, to computer vision and web scraping. So huge amount of space we can be, Python can be used for. It only the only limit is your imagination where you want to use it. But it comes with loads of packages and libraries that we can use it for almost any application you can think of. Okay. So when we look at jobs within the data science industry, data scientists, they focus on one of these five ideas or combination of these five ideas, depending on how we're using Python. So it can be used to, firstly, it can be used to identify data sources and automate collection. So if you know of websites from which you have to collect data, or you have sensor information coming in from different places, we can automate how the data is being collected and stored. And that is one part that people work on. We can work on pre-processing the data and analyzing, doing some basic analysis to discover trends. So this includes cleaning of data, handling missing values, doing some basic visualization that helps us see how things are working out, what are the trends, and so on. Another major area that people work on is designing predictive models and machine learning algorithms. So this is where we is a huge part where we'll enter into machine learning, where how we allow algorithms to learn from the data directly. So humans are not sitting in the background coding how things will work out, what are the features and so on, but we'll allow our algorithms to learn from the data on different parameters, on different ideas, different shallow learning algorithms and deep learning algorithms. That is another major area that Python is used. Then it is used to perform data visualization. So having data is one part of the story, but having visualization is having interactive visualization that can show trends, and that can view the same data in different ways, creating a story out of the data, storytelling and so on, is again another major area where Python is used. And finally, to deploy the solutions, to propose solutions and business challenges and deploying them to the market is another major area where Python is used. So top companies of the world use Python, starting within different spaces. So within the finance space, we have Goldman Sachs, PayPal, JP Morgan, and so on using Python. Within technology, we've got Google, Firefox, Dropbox, Mozilla using Python. We've got government government entities using Python, like NASA or CIA and so on. We've got travel. So depending upon different domains, you've got travel domains, we've got advertisement domains, entertainment domains. And all of those guys are using Python. When we look at the analytics salaries in India, depending upon the number of years of experience, we see that uh, from 2018 to 2019,
Elita, just
analytics salaries, yeah.
yeah. So like all the data science, what we are doing, like, is it like only on the available data, or like do we get that? I mean, like all these steps will be done only on the data that we have before. Is that, or
Mhm. Data have we had before, and what is the contrast to that?
I mean, like, do we extract the data or just like?
Yes, so both. Generally, once you're talking about data science, we go with the assumption that data is already available. But it also includes when data is not available and how do we collect data. That is also a major part of analytics. So something like ETL, extract, transform, and load, where you don't have the data within the right format for your algorithm, but a huge part contains of how do you collect that data from different places. So the data can come from surveys, or they can come from websites that are traffic from the websites, or data can come from another source. So someone else, maybe you are a company that is working on financial instruments, but your stock related data and how the market has been moving historically, that data is available online in other sources. So how do you get data from those sources to your machine learning solution? How do you analyze it? That is also one part of how we work at. So all of this comes under the first part, identifying different sources and automating collection.
Oh,
So it again depends from a case to case basis. If you already have access to data, we can directly use that data and do the next steps. But when we don't have access to data, we go around and collect data. So Python can be used for those things as well. In our course, in our small course, we have limited our attention on assuming that the data is already present. In all of our project cases, we'll go with data that is already present and doing analysis over that. But data collection is also part of your within the whole scope of data science. Okay, does that answer your question?
Yeah, that's good. Yeah, I understood.
Okay. So yeah, so here this just basic overview of what we'll be doing. So we'll be setting up the environment and have the setup ready for doing Python programs. And for our case, for data science, we'll generally stick to Jupyter notebooks as being the primary way of writing code and writing material and creating your workbook entirely. And probably by this time your download must have finished. So you said you've already installed Anaconda. Now we can probably move to see how a Jupyter notebook looks like. Further, within this part, we will look into operators and control structures, how different data types are written in Python, how do we write functions, writing object-oriented programs in Python, and just the basics of those things. Okay. Let me. Okay. Can you share your screen? I'll give you access.
Yeah, sure.
Okay. Okay. Maybe you can start with opening the Anaconda Navigator.
Okay. So you're from Hyderabad, Elijah?
No, I'm from Mumbai.
Ah.
So presently, I'm working in Bangalore. I moved here like 2 years back. I think it's open in the background. You click on that? Yes. This you can close. So we've got Jupyter Notebook. That's the second one. You can click on launch. Can you try clicking once again? I think it does not start. No, okay, start. So, so in the background, it's opening up. Yeah, in Chrome. So Jupyter Notebook basically it hosts a service uh, on this port 8888, and you can access that through your browser. So we generally be working within a browser framework, and the tree down shows you the different places within your where it is hosted. What we can do is you can if some of this looks familiar, you can probably create a folder within desktop or documents where you feel comfortable, and you can store all of your programs there. So here, if you want to create a new folder, on the right side, uh, uh, top right side, there is a button called as new. Yeah, no, just go down, little bit down. Yeah, can you see upload?
I can see that.
Next to upload, there is a button new. Click on new to create a folder. I think it has come as untitled folder down. You can click on the checkbox below Python scripts. Click on the no, go back. So to go back, you maybe can you share me access? I'll
Yeah.
So here by clicking this, you can go to the one folder up. This selecting the checkbox, and we can rename this folder. So maybe we can have data analytics. And I'll create maybe one more folder for Python basics. Okay. So within this area, within document data analytics learning Python basics, to create a new notebook, you can click on new and notebook Python 3. So yeah, that opens up a new notebook. We can name the notebook by clicking here. So say hello world. Okay. And within this interface, this is called as a cell. So we can have multiple cells if I just keep on pressing plus here. So each cell is where you can write different pieces of code. Okay. So now each cell can be either code or different things. So we use a markdown so markdown is where we can format this as text. So let's say I want to give a title. I will use a single hash uh, with space gives me heading 1. Okay, so let's say this will be my title. To execute this, I can either click on run here. So when I execute this, this gets formatted as title. Let's say I want to format the subtitle. I click this again, turns that to the markdown, and I put two hash, and then do subtitle. Click run. Will be spawned. So let me put some name here. So let's say into Python basics. Subtitle would be something like. Then by default, this is a piece of code, and I can write code here like let's say a is equal to 123, and when I execute this, let's say if I press A and run this, I can see that A has stored the value of 120. The number here, 1, 2, or 3, it shows in which order they have been executed. So within this, when you look at this at this point, we can see that this cell was executed first, then this cell was executed. Let's say if I modify this, maybe 34, and I execute this again. Now the number has changed. So this was the latest execution tree. So here in Python notebook, in Jupyter notebook, the order in which uh, we have written the document is, of course, it matters as such, but depending upon how you have run, this number tells you which code has latest been run, and accordingly, we can make sense. So I like in a normal idea, we should not go up and make modifications. We can always keep going down and make modifications so that the code is reproducible by other people. If you write some piece of code, then you go up and you modify the code. You could just keep an account of what things are happening. So it gives us certain freedom, but that freedom comes at the expense of uh, reproducibility. Okay, so we have to be a bit careful, or we should have good practices, and as we write notebooks. As we go ahead in the process, we learn about different operators and how to use Jupyter notebooks. I'll tell you how we do this. Okay, so apart from these basic things, there are many shortcuts that we can use to better or make things faster. So let's say here, when I've clicked on this, the entire cell is selected. So we are into this command mode by showing by this blue sign. Okay, and if I press inside, this becomes green. So I'm in edit mode. So whatever I write now will be written within the text. Okay, but let's say if I press on escape, I go back to command mode. Now there are certain shortcuts. So let's say if I want to create a cell above my present cell, I use the shortcut A. So when I press A on my system, I pressed it once, so it created a cell above the present cell, and that cell got selected. If I press A again, another cell will be created above it. Okay. If I press B, a cell will be created below the selected cell. So I pressed two times. Now two cells were created here. Okay. Other way to add cells is I can click here, I can press on this plus sign, that will add cell. Okay, so initially it is fine to use this, but soon you will find out that we'll be creating a lot of cells. So if we know the shortcuts, it will be much easier. Further, if I want to take a cell and convert that into a markdown like this, in the command mode, I can press M. When I press M, you see this in here, which showed that this was a code, that has replaced, and this becomes a markdown. Then I can click here and I can write stuff. So I can say this is my first Python experience. Just okay. Now to execute the cell, I can either click on run, or there are different ways. I can press something like Control and Enter on my keyboard. When I press Control and Enter, this gets executed. Okay, so it gets executed in the sense this was just text. It becomes like part of the document. But if I write code like b is equal to 5, if I want to execute this, I can press Control and Enter, and it gets executed. The way I know it gets executed is there is a number here, and this number tells this number is 4. That means out of all these is the latest cell that has been executed. Okay. Yeah. So yeah, we'll see more shortcuts on how we can work things out in the Python environment. This environment is called Jupyter Notebook. It is the most commonly used environment for people who are doing data science. Okay. Okay, great. So good. So we have confirmed that Python is running on a system. Maybe let us stop here, because the next logical unit is once we start with operators and control structures. So if we start now, we'll not be able to finish in the next half an hour. We can probably continue from next class,
Okay.
and I'll share to you my screen again. So what I'll do is within the same Excel, uh, I'll maintain a record of the different sessions that we have done,
Okay.
date, time, duration, what we have covered. So it will just be a place where we can quickly see how much we have done, where we are right now, and then how things will move on. And we were recording this session, right? So I will the recorded session. I will store that on YouTube as a private video, and I will share access of the video to you so that you can check our recording. And so earlier I used to put it on my Google Drive, but as the number of students increased and as the number of recordings increased, soon my Google Drive exhausted. So the only way that I found is where we can still have access to all of the videos and keep it private is having private videos on YouTube. Okay.
Okay.
So we'll do it that way. And if you want in Google Drive, I can share that, but then we'll have to empty it from the drive again because we'll quickly see that we'll run out of space. I'll stop recording for now.